So on last time we were discussing about the transportation problem and its overview. And we have two proofs, two theorems. One is for necessary and sufficient condition for the existence of solution to a transportation problem. That was summation AI is equals to summation BJ. And otherwise the feasibility of the solution, that is the number of feasible solutions will be m plus n minus 1 at any stage. Sorry, the number of basic variables at any stage of the transportation problem will be m plus n minus 1. So now today I am going to discuss how we obtain the solution to the transportation problem. So first I will give an overview again. What is the transportation problem? So the transportation problem arises when same goods is to be transported from different sources to different destinations in such a manner that the total cost of transportation should be minimum under the condition that the goods can be transported from one source to more than one destinations, as well as one destination can receive the goods from more than one sources. The per unit cost of transporting goods from different sources to different destinations may be different. And for finding the solution, sometimes I would use word rim requirement. So rim requirement is nothing but the availability and demands are simultaneously called as rim requirement. So how we obtain the solution of transportation problem? So earlier we have discussed that the transportation problem can also be represented in the terms of linear programming problem. That is, transportation problem is a special case of linear programming problem. But and we can solve transportation problem in same manner as simplex method or big M method or two-phase method as we solve the linear programming problem. But there is a problem that there will be only m plus n constraints in m into n variables. That means if we have 4 rows and 5 columns, we have only 9 constraints and 20 decision variables. That means we have to do a lot of work for solving transportation problem by means of linear programming problem. Therefore, instead of using simplex method, we prefer some other methods which are defined for only for transportation problem. Any transportation problem can be solved into two steps. In step 1, we obtain the initial basic feasible solution for the transportation problem by using any of defined methods, among which main are northwest corner method, which is also called as NWC method. Second is least cost method, which is also called as matrix minima method. And third is Vogel's approximation method, which is called also as WAM. And in second step, from by using these initial basic feasible solution, we can obtain optimum solution to the transportation problem by using following two methods. One is called as method of multipliers, or it is also called as it is also called as modified distribution method, which is in short called as Modi method, and other is called as stepping stone method. So today I will discuss how we obtain the solution of transportation problem using northwest corner method. So before obtaining the solution of transportation problem or initial basic feasible solution to the transportation problem, two conditions must be checked. First condition is whether the transportation problem is balanced. That means the total availability is equals to total demand. Or in other words, we can say that the condition necessary and sufficient condition for the existence of the feasible solution of a transportation problem, that is summation ai is equals to summation bj. That means first we verify whether summation ai is equals to summation bj or not. If not, we add one row or one or more rows, sorry, one row or one column, depending upon whether demand is smaller or supply is smaller. If supply is smaller, then row is added, and if demand is smaller, then column is added, and the cost in that introduced row or column will be zero for all the cells, and the rim requirement for that row or column will be that equals to the difference of the summation ai and summation bj. That means the difference between total demand and total supply. And the column or row added or introduced are called as dummy row or dummy columns. Secondly, we have to check whether the problem is of minimization type, as the transportation problem is defined to minimize the total cost. So the objective of the transportation solution of transportation problem is minimization of total cost. So it is required to check whether problem is minimization type or it is of maximization type. If it is of minimization type, then it's okay, but if it is of maximization type, then it is required to convert into the minimization type problem. For converting the maximization transportation problem into minimization type, any of following two methods can be used. That means either method 1 or method 2. In method 1, we can multiply each and every cost by minus 1. That means all the cost will become negative. Or there is another method. In that method, we obtain the maximum profit, or the quantity we want to maximize, which is maximum quantity, and subtract it from the quantity in each cell. That means if it is profit, then we find maximum profit and subtract it from the profit given each cell, including that one also. And these checks are performed in the same order. That means first we check whether summation ai is equals to summation bj. Then we check whether problem is minimization type or maximization type. If we change the order of these check, then solution will be misleading. So for obtaining the initial basic feasible solution, we can use three methods, which are called as, I have already told, northwest corner method or NWC method, other is least cost method, and third one is Vogel's approximation method. For explaining these methods, I am considering the following example, which is solve the following transportation problem in which the table consists of per unit transportation cost. In table, first column shows the sources, second to fifth column shows destination, and sixth column shows the availability at the sources. And last row represents the requirement H at each destination. So we have four sources A, B, C, and D, and four destination 1, 2, 3, and 4. For transporting one unit to from source A to destination 1, the cost will be 4 units. Similarly, for transporting one unit from source A to destination 2, the transportation cost will be 6. The availability at source A is 500, availability at source B is 700, availability at source C is 300, and availability at source D is 350. Similarly, the requirement at first destination is 250, at requirement at destination 2 is 350, requirement at destination 3 is 1050, and requirement at destination 4 is 200. Now we have to obtain its initial basic feasible solution. For obtaining the solution using northwest corner method, only two steps to be applied. First step is to select the northwest corner of the transportation problem and then allocate the minimum of availability and demand corresponding to that cell at northwest corner to it and subtract the allocated quantity from the availability as well as the demand. And second step states the repeat step 1 till all allocations are not made, or in other words all the rim requirements are not fulfilled. So we consider the problem. We can represent that problem in the form of this table. Here we have made two cells for each source as well as each destinations. Here in this part, that is upper rectangle, we represent the quantity that should be transported from source to the destination. So before going to obtain the solution, first we check the two conditions. First condition, that total availability should be equals to total demand. So total availability is 500 plus 700 plus 300 plus 350. So 7, 5, 12, 315, 318, 1850 units. And requirement is 250, 350, 1050 and 200. That means 235, 1600, then 1650 and 200. That will become 1850. That means total of requirement is 1850 as well as total of availability is also 1850. So the problem considered here is balanced transportation problem. That is total availability equals to total demand, or you can say summation of AI is equals to summation of BJ. The second check was whether the problem is of minimization type or not. So the question states that in table these quantities represented are per unit transportation cost. So total cost should be minimized, it cannot be maximized. So our problem is of minimization type also. Now we made allocations. So for making allocation, first we see this diagram which shows the directions: upside north, right hand side east, below is south, and on left hand side it is west. So northwest will be at this point, that is this corner will be northwest. If we put this diagram on the table, then we obtain that this corner is the northwest corner of transportation problem. We You can say that this is the northwest corner, but we will not consider it. We will consider the corner from which we have to start allocation. So from this point we have to start the allocation. So it is the northwest corner of the transportation problem. Now corresponding to it, availability is 500 and requirement is 250. So among 250 and 500, 250 is minimum. So we allocate 250 to this cell. So here we write the quantity 250, and in same manner we subtract this 250 from the availability. That means remaining availability will become 250, as well as we subtract this quantity from the requirement. That means 250 and 250 minus 250, the difference will become 0. That means requirement of destination 1 is fulfilled. Now we ignore this and then find next northwest corner. If we eliminate this column, then our northwest corner will become here at this place. Now the remaining availability is 250 and requirement at destination 2 is 350. So the minimum is 250. So we allocate in this cell also 250, and subtract it from availability, remaining availability, as well as from the remaining demand. So we obtain this table. That means first allocation was 250 and second allocation is also 250, and we subtract 250 minus 250. So availability of source A is now fulfilled, that is remaining availability is 0. And from in demand we also subtract 250, so 350 was the total demand at destination 2. 350 minus 250, it will become 100. So the demand at destination 1 is fulfilled, as well as availability at origin A is also fulfilled. Now, now after, so we can eliminate first column as well as we can eliminate first row. Now after eliminating these two, we will get the next northwest corner at this point, that is source B destination 2. At this point the demand is 100 and availability is 700. So minimum of 100 and 700 is 100. So we put in this place 100 and subtract it in from remaining availability and remaining requirements. So we place 100 here. The demand at destination 2 or requirement at destination 2 is fulfilled. That is remaining requirement would become 0. And available, subtract 100 from availability, it will give 600. That means now we can eliminate first two columns and first row. After eliminating or ignoring these, our next northwest corner will be source B destination 3, that is this cell. Now at this cell availability is 600 and demand is 1050. So minimum is 600. At this cell we allocate the quantity 600. So when we allocate 600 to here, then availability at source B will become 0 and requirement at destination 3 will become 450. Now after we can eliminate source B also. So after eliminating destination 1, destination 2, source A and source B, the next northwest corner will be this one, that is source C and destination 3. At this place the availability is 300 units and demand is 450 units. Minimum of these two is 300, so we can allocate the quantity 300 to this point. So after allocating the 300 at this point, our availability will become 0 and demand will or requirement will remain 150. That means for availability 300 minus 300, that is remainder is 0, and for requirement 450 minus 300, so remaining requirement will become 150. Now third source can also be eliminated. That means we can eliminate first three rows and first two columns. After that we would get next northwest corner at this place, that is source D and destination 3. The availability is 350 units and requirement is 150 units. That is minimum rim requirement is 150. So at this cell we allocate the quantity 150. So after allocating this, the requirement for destination 3 is also fulfilled and remaining requirement is available only for destination 4 and availability is at only destination D. So we can allocate the remaining quantity at the intersection of these, or you can say the next northwest corner, which is at source D destination 4. That means this place. So we allocate 200 quantity 200 here, and we can see that our all the remaining requirements will become 0, as well as all the remaining availabilities are also 0. That means all the allocations are made and we can say that all the rim requirements are fulfilled. So it is the initial basic feasible solution to the given transportation problem by using northwest corner rule. And you can check the second condition which we have proved, that any stage of feasible solution of transportation problem, there will be m plus n minus 1 basic variables. That means there should be m plus n minus 1 allocations. M is number of rows and n is number of columns. So here we can see there are 4 rows and 4 columns. That is m is equals to 4 as well as n is equals to 4. So m plus n will become 8 and m plus n minus 1 will become 7. Now we count allocation. So it is first allocation, it is second, it is third, it is fourth, it is 5, it is 6, it is 7. That is we have made 7 allocations. That is second theorem is also verified with the help of example, that at this stage the number of basic cells or number of basic variables, or you can say allocated cells, is m plus n minus 1, which is 7. Now how we represent this solution? We represent the solution in the form of this table. That is, you can see the 250 quantities, 250 units of goods is transported from source A to destination 1. So we can write from source A to destination 1, quantity transported 250, and cost of transportation will be 250 into 4. 4 is per unit transportation cost from source A to destination 1. So for 250 units, it will become 250 into 4, that is 1000. In same manner, from destination A, sorry, from source A to destination 2, the quantity transported is 250 and cost will be 250 into 6, that is 1500. Similarly, from source B, we can to destination 200 units are transported. So cost of transportation will be 1100. From B to 3, 600 units are transported and transportation cost will become 6000. From C to destination 3, 300 units are transported. So transportation cost will become 3000. From source D to destination 3, number of transported units are 150 and transportation cost will become 1950. That is, multiply 150 with 30, it will give 1950. And here it is written E, but it is originally D. That is, we transport from source D to destination 4 and quantity transported is 200. So the cost, transportation cost will be 600, as the per unit transportation cost from source D to destination 4 is 3. So it will become 600. Now we can add these transportation cost, then we get the total of 15,150. That means the total transportation cost obtained by northwest corner method is 15,150. Here we cannot write minimum cost, as it is not an optimum solution, it is initial solution. As it is initial solution, we write total transportation cost, we will not write minimum transportation cost. Now these are the references, I have already told about these to you. So it is the end of today's lecture.